I'm Phil, and today I'm going to look at more advanced projects using the Maqueen Plus version 3. So let's have another look at what Maqueen looks like. So Maqueen is a robot based on the microbit computer. And here on top, I've got the matrix laser array, and the microbit plugs in onto the base on the bottom. So we might actually have a look at what some of the extensions are for this. Okay, so the specifications, we've seen this before. It's got excellent line tracking with algorithms for line tracking built in. The matrix laser range sensor is unique to Maqueen, and there's quite a lot already on board. But what's interesting is that you can also extend it. So I'm going to extend it with HuskyLens, which is an AI camera, and it's going to do things like line tracking using a camera, but it'll also decode images and help me with navigation. I'll be adding the IR remote, and you can either use the unit that comes from DFRobot, and I've only got one of these, but I found that the MakeBlock IR controller also works, but the buttons are different. They have different codes. The time of flight and the flashlight unit come from M5Stack, and I've also added those. So we might have a look at what my extensions look like. So here is my preparation to add the extensions, and I can add Lego components, and I can add the make block components. And this is all nice because the extension and the holes that are there for additional components are all Lego compatible. That is, the spacing allows me to put in Lego components or M5 components quite readily. Okay, so we might have a look at what some of those extensions are. These are the projects that I've done. And since I've done the demos and the move along a route in the last video, I'll have a look at some of the new projects that I've worked on. So one of them is the lifter project, and this one we'll see in the video very shortly. What it has in the hardware is the microbit, the Maqueen, a IR remote controller, and that'll be used to control the lifter. Software-wise, I'm using MakeCode with extensions for servos, and this is what the code looks like. So we might go across and have a look at the code and also the desktop demo for that. So if we go across to MakeCode for microbit on Chrome, this is the program for one of the catches on the robot Maqueen Plus version 3. And what I'm doing here is we might actually go through it step by step. We'll have a look at the initialization at startup. We initialize, but we also add on not only the Maqueen, but we add the servos extension. And on startup, we're initializing the I2C bus for Maqueen, and we've got the line following settings, and the next one initializes our servo on port 0. In forever, we do obstacle avoidance data, we get that, and we detect the distance and show that on the serial port. When we press button A, we move our forklift or catcher to 110 degrees, and that's the down position. And when we press button B, which is 3 on the remote control, we lift the forklift. And we can do all that with the IR handheld remote. And when we get a code of 1, we can also lower the forklift. Or if we get a code of 3, we can raise the forklift. And that's the code for one of the catches on the Maqueen Plus version 3. So I was quite happy with the results on that. I was able to move the servos from, in the case of the forklift, from the upper position to the lower position, and that would allow me to collect cargo. And I could use a controller, either the handheld IR remote or microbit's buttons A and B. So the next series of projects are all based on using HuskyLens with Maqueen. And the ones I'm going to show you, I'm still working online following using HuskyLens, which is a AI camera. We'll have a look at using tags and taking photos. So using tags, the primary objective here is that I'm going to get microbit to recognize April tags. And what we're going to do is have 3 different tags, one to enable the robot, that will be tag 3. We're going to stop the robot and we can start the robot. And the objective or the object will be April tags. And we'll show the results on the HuskyLens LCD. So the secondary objective is that we're going to demonstrate the forklift. And background, this is what our April tags look like. We'll only be using 3 of these, and there's a much bigger range of these available. Hardware-wise, microbit, Maqueen Plus version 3. We've got the handheld remote and HuskyLens. And here is our software. So we're going to use MakeCode, and we're going to use the extensions both for Maqueen version 2 and 3 and HuskyLens. And here's our code for that. So we might go across and have a quick look at that. So on MakeCode, this is our code for our decoding the April tags. So let's go and have a look at it. This is the overall code. So we'll zoom in so you can get a better look at it. So we've got on the start, we initialize Maqueen, and we're also initializing the HuskyLens. And there's a separate set of commands for HuskyLens being added via the extensions. So you see we've got Maqueen, the IR, the matrix LiDAR rangefinder, HuskyLens, and the servo all added as extensions. And what we do, the first thing we do, we show which version and the name of the program on the HuskyLens LCD screen. We initialize the servo, and we also initialize all of our parameters. So then we set the name of our current algorithm. And this is really the tags. The April tags are going to be ID 1, 2, and 3, and they're all set at start, stop, and enable. In Forever, we call 3 functions. Get object, which is really getting the April tag. We show what that is, and we can do some line following. And if we have our transmit flag on, we call the serial routine, and that helps us with a bit of debugging. I won't go through all of the functions, but this is the function for the forklift control, and we've gone through that before. Getting the object's very simple. We just simply get the April tag from HuskyLens, and we set that to tag and show it on the screen with the second object. When the logo button is pressed, we, depending on whether the transmit flag is on or off, we can show the state and stop the motors if that's moving. For button B and A, we're using the buttons there for controlling the forklift. And that's our program for tags, using tags on HuskyLens. This is the HuskyLens camera on Maqueen version 3. And the camera's on the front here. There's the overall robot. And we're going to detect this green Lego brick. And we can see everything on the screen. So if we go over here, we can get the parameters. There we go. We've got the colour brick. And if I move the brick with my hands, you can see that the coordinates will also change. So we have to wait a couple of seconds. There we go. I should be able to identify it again. There we go. We've got the coordinates now. And we can also see that on the screen. So we've got the coordinates X and Y and the number of coloured bricks, and we can go across and see that on the serial port. So we've got the parameters here, and we're going back up now. We've got the latest parameters, and that's on the microbit MakeCode serial monitor. I was quite happy with the results there. We were able to achieve the primary objective to get the microbit to recognize tags, and we were using HuskyLens to do that. And we used 3 different tags. That is the enable, the stop, and the start robot. We could also track the line on the line map, and we were using the April tag system on HuskyLens. The secondary objective was to demonstrate the forklift with the IR controller. Any issues on that? There are more recent versions of April tags. I tested those and they didn't work. So we'll repeat that once again. So what we'll do is enable, then start. And we're going to use the stop tag. When it comes back, and that is how we use April tags to control a robot. The next project for using HuskyLens on Maqueen was to get it to take photos. So the primary objective was get microbit with HuskyLens to take a photo and show that on the LCD screen. And the secondary goal was to put that on the screen and to record the time and the date and the photo number also on the screen. So in effect, we've got a digital camera on our Maqueen robot. And we want to take pictures with the remote control or the microbit button A and B. Button A for taking photos and button B for taking screenshots. And we're going to save the photos onto an SD card. So we've got the same combination of hardware as we had before. And for our, I've upgraded the firmware for the HuskyLens, and you can only do this program if you're using the latest version. You need to use the extensions for both Maqueen and HuskyLens, and here's my program. So what we might do is go across and have a look at that now. So here's our program on MakeCode for our camera on HuskyLens. So right on the top, we'll zoom in and see how it works. We're initializing the program, and we show on the text that both the version and the program name. We're also going to use a software real-time clock, and we're going to capture both the date and the time, and that will be put as a stamp on our photo. So when we press button A, we take a photo. We press button B, we take a screenshot, and we can also take a screenshot using code 7 or 24, but it's button 7 on our IR remote. So when we take a photo, the function here allows us to capture the year, month, and date, and that's shown on the photo, together with the title. And when we take a screenshot, it's similar. Okay, and that's the software for our camera on the HuskyLens. This is HuskyLens, a AI camera on the Maqueen Plus version 3, and we're ready to take photos. So all I have to do is on the handheld IR, press button 7, and you can see the image now on the LCD screen of HuskyLens. So let's take some photos. Okay, we've taken our first photo, and we've got the date and the number recorded on the screen. And this is our photo of the fish tank. So again, this program worked very well. We achieved the primary objective to take photos. We showed those on the LCD screen, but we also put them on the microbit, on the micro SD card. And here are some of the photos in our results that we took. So there we go. We were able to take quite a number of photos using that camera. And we had overlays for both the name and the version of the program, together with the time or the date stamp. We could have added the time stamp on the right, but I didn't do that. Okay, so quite successful, and we can use that on our Mars rover to take photos. The next project is to add a flashlight for our camera. So what we're going to do here is to, let's have a look at the desktop arrangement. I'm adding an M5Stack flashlight, and when I press the button, it will, or if I press button A, it will turn on the flashlight so I can take a photo. And this is only a unit test, so I'm really just testing the on-off control in this particular demonstration. And software-wise, the MakeCode, I'm adding the extensions for the Maqueen and HuskyLens, but I don't really need them for this program. I'm just using very simple code, which is controlling the digital pins on port 13, and that will either turn on or turn off the flashlight. And stay tuned, and we'll have a look at a desktop demonstration of that. Quite happy with the results. The next project is to look at a time of flight distance sensor. And again, I'm using an M5Stack time of flight. So it's on the right of my Maqueen. And uh, been able to secure that with the Lego pins on the time of flight unit. And I'm using a mate block uh, component there to secure it onto Maqueen. Okay, so we'll have a look at the objective. I just want to test it to see if it works. And these are all the components that I'm using. The time of flight comes from M5Stack. So this is the what the unit looks like. And to get it all going in software, we use extensions. The extension is the time of flight rangefinder, and this works quite nicely on the code. The code's very simple. So again, this is only a unit test, and what I'm doing is collecting the distance measurement and showing that on the microbit LED display. Happy with the results on that, and stay tuned for a desktop demo. So to help HuskyLens take photos, we can see that it's taking a picture of Mars on the screen. We've added a flashlight, and here's a flashlight here. It's connected to a GPIO pin on the bit on the microbit. So to get that going, as a demonstration, this is just a unit test. When I press button A, the flashlight will go on for 2 seconds. And finally, for some future projects, one is I want to look at renaming the objects on the HuskyLens program. That's quite simple. It's hardly a project. It's just really just testing that feature. I want to look at the obstacle profile using the matrix laser rangefinder. And that should be able to take a profile of the obstacles and allow me to determine a path for my Mars rover. So it not only can have a look at obstacles, but it can look at the profile and the height of the obstacles. I want to add a weather station for my Mars rover, and we'll be using the BME 280. That should be quite straightforward. Communications-wise, I want to use communications between 2 microbits. One will be the Earth station, and the other one will be my Mars rover. And getting back to Earth, I'll be looking at building my own speed camera using the digital camera. This will be a mobile speed camera. I'll be looking at how Maqueen and HuskyLens can react to traffic lights, and also variable message sign using e-ink signs. Then we'll do some voice control and perhaps AI interaction with Maqueen for robot control. And they're my projects, the extended projects for the Maqueen Plus version 3 and HuskyLens.